Universal law of gravitation. So this universal law of gravitation is given by the scientist Newton. So it is a famous law of gravitation given by Newton. Okay, so he takes that if there is a two masses, so the big mass of mass capital M, and this is another body of mass small m. Both are separated by a distance d. So dear students, the distance is taken from center of this mass to center of this mass. Let us we take that this is the body A, this is the body B. What is the universal law of gravitation says means the force of attraction, the force of attraction between. So why it is only attraction, sir? So gravitation force is always attractive force, not a repulsive force. The force of attraction between the two bodies which are separated by a distance d is proportional to, that force is proportional to product of the two masses, and that force is inversely proportional to square of the distance between them. Hence we can say that this law is also called as inverse square law, because the distance between the two bodies will be inversely proportional to square of the distance between them. Hence we can write that this force, gravitation force F is proportional to m by d squared. So in physics, whenever there is a proportional, so directly proportional, we have to remove this with substituting constant. So if you put F is equal to means we have to put one constant is called as a gravitation constant, gmm by d squared, where G, this is a force of gravitation. This force is a vector quantity. So what is a vector? The vector means which has a magnitude as well as a direction. This direction is towards each other. So the force is F is equal to, gravitation force is equal to gmm by d squared. This N is a Newton, SI unit of force, where G is equal to, the value is 6.67 into 10 power minus 11. 6.67 into 10 power minus 11. What is the unit of this G means? Very simple, students. The unit can be calculated. No need to mug up any units. So G is equal to F d squared by m. So I will keep this G as it is. D squared and mm will come down. So what is the SI unit of force? Newton. The distance can be measured as a meter. So meter squared by mass into mass. Mass is a kilogram. So it is kilogram squared. So we can write the SI unit of gravitation constant is Newton meter squared kilogram power minus 2, because the denominator will become numerator. So what is this? Very simple, students. Once again I will recall you the universal law of gravitation given by the Newton, scientist Newton, is it states that the force of attraction between any two bodies in the universe is proportional to, that is proportional to product of the two masses and inversely proportional to square of the distance between them. So this proportionality can be removed by F is equal to gmm by d squared. This is the SI unit of force Newton. So where G is called as gravitation constant. G is a gravitation constant. This gravitation constant is found by a scientist named Cavendish. By using the Cavendish experiment, he found that that value is 6.67 into 10 power minus 11 Newton meter squared kilogram power minus 2. Dear students, already I told that this law is called as a inverse square law. This law is also called as inverse square law. So one small example. So if the distance between these two is 6, we will take that d is equal to 6 means what is the d square? D square will become 36. If the distance is 6 meter or 6 kilometer or factor whatever it is, if the distance is 6 means the d square is 36. So what will happen? We can say that if d gets bigger by the factor 6, f becomes 1 by 36 times smaller. So if the d increases, this f become, what is that? Decreases. As the distance increases, force become smaller because both are inversely proportional. So you can ask one question. So this gravitation force is applicable for, this is a sun, this is a earth. So the distance between these two is very long, sir. Hence this force is very smaller force, sir. Yes, it is true. The gravitation force is a least magnitude force or a very smaller force in the universe. So there are a large number of forces are available. Electrostatic force, then nuclear force, gravitation force. Among these, gravitation force is the weakest force because the gravitation force is applicable only for long distance objects. The distance between the two bodies are very larger means then only the gravitation force come into effect. So you can ask that if the distance is larger means the force is very smaller, sir. You have to consider that it is inversely proportional, but the force is directly proportional to masses. Imagine what is the mass of the sun and the earth. It is a very huge mass. Hence, that huge mass provide the force. So, the force factor will depend upon both the distance and the masses. That force is responsible for the moon revolving around the earth or sun is revolving around the earth. So, that revolution will be given by, circular motion is given by centripetal force. Already we are discussed in last video.